A friend of mine wants internet access while he's outdoors, working in the garden or whatever, and he's been mounting routers outside of his house. I don't usually recommend doing that because of the dangers of 110, 220 volts. He mounts them up underneath the eaves of his house. He's got really big eaves. They're about 2 meters wide, and so there's no direct sunlight, no direct water hitting these. But they don't last very long. A year, year and a half, they go flaky, they go bad, and he was wondering why. So he gave me a couple old ones. Let's open them up and see what's going on inside. Let's look up close at what happens when you do expose a board to moisture, condensation, water. Here you can see inside the ring light we're getting, it's basically dust. It's mud, if you will. It's dust combined with moisture, and it is connecting the tracings. So these tracings are painted, but still there will be, with high frequency that will change the frequencies involved. But you can see a little bit of corrosion starting here. Let's go find another place. Here you can see more buildup of minerals, dirt, what have you, and perhaps a little bit of corrosion. Over here you can see flux migration. See these little trails running off? They look like little drips, but they're running off in all directions. So this is getting wet. You can see the discoloration along the chip here, and that's not good because flux will carry electricity, especially when it's damp. You can see it over here in the connections. Let's go look at a really bad case of it. You can see some real serious flux migration where the flux is connecting both of the solder points together. Here you can see this looks like an old dried lake bed where it's, water's collected, then evaporated, collected, and evaporated. You see little rings around it. You can see some corrosion in here. You can see some corrosion here on this component labeled FB303. And then we get over here to this capacitor, and it's just rusting away. I mean, it's completely shorted and rusting. Over here we have some traces being attacked. And yeah, I mean, none of this is good for a high frequency component on a board. Here we have another capacitor that's completely been attacked and shorted. And yeah, I mean, each one of these components is important, and each one of them is being destroyed. And you can see over here more flux migration in another direction. So basically, out of this component over here, we've had flux migration in all directions. And back in here, you can see where again there's been water. These are near switches and so on, so that's never good to get water in mechanical devices, of course. You've got an inductor right there, and all this has had condensation and water build up on it. It's liquid water, when it condenses. So, some corrosion around the power plug. Yeah, none of this is good. And this is all on one device. This is not multiple devices. This is one circuit board. As a side note, these capacitors, normally I'd recover the capacitors off these boards. See how this top one is domed, this is domed. This one's relatively flat, and this one's domed right here. That's oftentimes a sign that a capacitor is going bad when the top starts to bulge up like that. This one is a lot flatter. I don't know if you can see that on the camera, but yeah, that's I wouldn't recover these capacitors. I'd just throw them away. This is a page from a Cisco router, and you can see where it says operating relative humidity 8 to 90% non-condensing, and even a non-operating is 5 to 95% non-condensing. This word non-condensing is important because when you have condensation, you have liquid water, like on the grass in the morning you have dew. When you walk outside you get fog on your glasses, or you see fog on the windshield of your car. That's all liquid water, and liquid water on a circuit board, especially a complex one operating at high frequency, you get liquid water and you get corrosion, you get mineral buildup, you get shorting basically, you get all sorts of bad things that interfere with the operation of the circuit board. So now we know why operating an indoor router outdoors makes it fail pretty quickly. Well, that was it for today. I hope you find it useful and interesting.